Okay, so let me guess. You've got the JavaScript basics down, right? But now, what's next? It's kind of fuzzy. You keep hearing these buzzwords thrown around, like TypeScript, closures, the event loop, and yeah, they can sound super intimidating. But that's exactly why we're here.
Yeah, you've nailed the fundamentals. You know, your if statements, loops, functions, all that good stuff. But now you're kind of stuck at a crossroads, aren't you? You're seeing cool frameworks like React. You hear people talking about all this advanced stuff, and you're just thinking, okay, where on earth do I even start?
Well, here's a little secret for you. These advanced topics, they're actually way easier than they sound. Seriously, it all comes down to how they're explained, and that's exactly what we're going to do right now. We're going to break it all down. Ready? Let's get into it.
All right, part 1, JavaScript's unique type system. First things first, let's talk about something that's, well, a little quirky about JavaScript, and that's how it handles data types. This is one of the biggest things that makes it different from a lot of other languages out there.
So JavaScript is what we call dynamically typed. What does that even mean? Well, it means a variable's type isn't set in stone. You could have a variable say let age equals 25, and then later in your code you can just decide, you know what, I want this to be a string now, and change it. It makes the language feel super fast and flexible, right? You can just start coding. But, and this is a huge but, it can be a recipe for some really sneaky bugs when a value suddenly isn't the type you thought it was.
And it gets weirder. On top of that, JavaScript also does this thing called type coercion. It basically means it automatically converts types for you kind of behind your back. For example, in an if statement, the number 0 will just magically be treated as false, and pretty much any other number is treated as true. It can be handy sometimes, but yeah, it's another one of those little quirks that can make you scratch your head wondering why your code isn't working.
So with all this flexibility, you're probably thinking, okay, this sounds kind of chaotic. Isn't there a better way? A way to add some structure and catch these mistakes before they blow up my application? And yes, oh yes, there absolutely is.
And that's where TypeScript comes in. Think of it like JavaScript, but with a safety net. You get to add static types. So you can say, hey, this variable has to be a number, or this function must return a string. Now, TypeScript itself doesn't run in a browser, it just compiles down to plain old JavaScript. But its superpower is that it acts like a coding partner, catching your mistakes and giving you warnings as you type, long before your code ever sees the light of day.
Okay, moving on. Part 2, unlocking functions in scope. Now we're getting into how you can really level up your code, and this is where JavaScript starts to get really powerful.
So let's talk about higher order functions. It sounds complicated, right? It's not. The key thing to understand is that in JavaScript, functions are just values. Seriously. Just like a number or a string. That means you can stick them in variables, and more importantly, you can pass them into other functions as arguments.
And you've probably already used these without even realizing it. Think about array methods like .map, .foreach, and .filter. When you use .filter, what do? You give it a little function that acts as a test. Then .filter runs your little test function on every single item in the array and gives you back a new array with only the items that passed. This idea, passing around pieces of logic like they're just values, is absolutely fundamental to writing modern JavaScript.
All right, next up is a concept that, okay, it can be a little tricky at first, closures. But here's the best way to think about it. When you define a function inside another function, that inner function basically gets a memory of where it was born. It gets to carry around all the variables from its parent function, almost like it has a little backpack. And that backpack full of variables, that's the closure.
So why is that backpack so cool? It's all about something called data encapsulation. It means you can have variables that are completely private, totally hidden from the rest of your code. But you can expose specific functions that are allowed to access and change that private data. It's the ultimate look but don't touch mechanism. Your data stays safe and private, but you provide a public, controlled way to interact with it. All right, part 3, organizing modern applications. So we've looked at types and functions. Now let's zoom out a bit and talk about how we actually structure big applications to keep our code from turning into a total mess.
The main way we do this today is with modules. Just think of each file as its own little self-contained world. By default, everything you write in a file is private to that file. If you want something like a function or a variable to be usable in another file, you have to explicitly export it. Then in the other file, you just import it. Simple as that.
Okay, now for a really core concept in JavaScript, prototype inheritance. Here's the deal. Every single object in JavaScript has a link to another object called its prototype.
So when you try to use a property on an object and it's not there, JavaScript doesn't just fail. It goes and checks that object's prototype. It's like asking, hey, you don't have this. Does your parent have it? This is why you don't have to define a property like inner text on every single HTML element in your code. They all inherit it from a shared prototype.
Now you might be thinking, this prototype stuff sounds kind of clunky to set up by hand, and you'd be right. That's exactly why modern JavaScript gave us the class keyword. But here's the secret. Classes in JavaScript are mostly just syntactic sugar. That's a fancy way of saying it's just a nicer, cleaner-looking syntax for doing the exact same prototype inheritance stuff we were just talking about. Underneath it all, it's still prototypes.
And now for our final section. We're tackling the big one, the concept that often scares people the most, asynchronous code. This is the magic that lets JavaScript handle slow stuff without the entire user interface just freezing.
So here's the puzzle. JavaScript can only do one thing at a time. It's single-threaded. So what happens when it needs to do something that takes a while, like fetching data from a server? If it just sat there and waited, your whole web page would freeze up. You wouldn't be able to click anything. So how in the world does it manage this?
The answer is something amazing called the event loop. Let's break it down. Step 1. Your normal code runs on something called the call stack. Pretty simple, one thing after another. Step 2. When JavaScript hits a slow asynchronous task, it doesn't wait. It hands it off to the browser and says, hey, you deal with this, I've got other stuff to do. Step 3. When the browser is finished, it puts the result into a waiting line called the callback queue. And finally, step 4. This is where the event loop comes in. It's like a bouncer. It's constantly looking at the call stack. The moment the call stack is empty, the event loop grabs the first thing from the queue and puts it on the stack to run. And that's the whole magic trick that keeps your pages responsive.
Now, to make all this asynchronous stuff easier to manage, we use something called promises. A promise is basically an IOU. It's an object that represents a value that you don't have yet, but you will, eventually. It's a placeholder for the future result of an operation, like that data you're waiting on from a server.
And every promise has a simple life cycle. It starts in the pending state. It's still waiting. If everything goes well, it becomes fulfilled. If something goes wrong, it becomes rejected. That's it. This simple flow gives us a really clean and predictable way to handle whatever happens.
So how do we actually use these promises? Well, there are two main ways. The traditional way is to use .then for when things go right and .catch for when they go wrong. But the much more modern and frankly easier way to read it is with async and await. This is more of that syntactic sugar we talked about. It lets you write asynchronous code that looks and feels like it's just running line by line, which makes it so much easier to understand.
And that's it. That's the roadmap. First, you master the type system and get some safety with TypeScript. Then, you unlock some serious power with closures and higher-order functions. From there, you learn how to organize big projects with modules and classes. And finally, you conquer the world of asynchronous code with the event loop and promises. See? Not so scary when you lay it all out.
So now you have the map. You can see the whole path from the basics all the way to the advanced concepts that really power the modern web. They all build on each other, and together they create an incredibly powerful toolkit. The only question left is, which piece of the map are you going to explore first?